We'll post it up on our website, get to it at a future date if needed. Just request everybody mute themselves. If you're not speaking and during the presentation, please put all your questions into the chat box, and we'll address them as we go along or at the end with our speaker. Any comments or questions at the end or later you want to get back to something that you maybe want to circle over to, again, phillysei@gmail.com. Today's topic is BIM for Bridges, a process overview. And we'll let everybody know that you can download today's PDH at our SEI website. I'll paste that link into the chat once we get going here. You can go there and download that for yourself. Should be available at this time. So today's speaker is Zach Ells. He's a senior structural engineer in our AECOM Bridge department in the Philadelphia office. Concentrating on structural engineering and analysis and design and construction phase services for highway structures, and really kind of leading the process for BIM or BRIM software for AECOM in the Philadelphia area, both in document development as well as client standards and configurations. So Zach, thank you for volunteering to present to us today. I'll ask if you can go ahead and take over the screen and take it away for us.
Sure, thanks, James. Share my screen. You see my screen?
Yes.
Great. So like James said, I've been working as a structural engineer for about 10 years now, with AECOM now. Working on BIM for the last few years. Currently, we're working on a pilot project right now that's looking to have a BIM deliverable. A lot of the examples from this presentation are going to draw from our experience with that project. We're creating a model for this project. We're going to run analysis through that. We plan to have plan presentation as long with the model for documentation for this project. We're about through preliminary design about 30–40%, but this project today, or this presentation today, is going to run over the full process of BIM from getting set up in the workspace and scope, getting involved with that all the way through delivery to the client, to construction management, and eventually asset management. So a few things just to start. I want to get a couple terms out of the way. BIM, BRIM, really interchangeable. BRIM is the new term we're using for bridge information modeling as opposed to building information modeling. They're pretty interchangeable. LOD is something I'll talk about quickly for our scope. LOD is a level of development that has to do with specifically elements within the model. It's important to identify how detailed you want to get with those. OBM is Open Bridge Designer, not to be confused with Open Roads Designer. The project we're testing out, we're using Bentley products, so most of my focus here today will be using those. Open Bridge Designer is the software that encompasses Open Bridge Modeler, the analysis programs, the Prostructures, which I'll get into in the next slide. LeapBridge Steel and LeapBridge Concrete are the two analysis programs that draw from Open Bridge Modeler. They are incorporated in Open Bridge Designer. That's LSB and LBC. Workspace is kind of the configuration that you set up to pull from for all of the model elements. A work set is a subset of the workspace that you can set up specifically for projects. And I'll get into that more as I get into configuration setup. Some of the programs that we're using and I'll focus on today, like I said, Open Roads Designer is more on the civil side, setting up corridors, geometry files. My focus is more on the Open Bridge Designer. Again, that encompasses Open Bridge Modeler, Prostructures, LeapBridge Concrete, and LeapBridge Steel. Like I said, the Leap products are the analysis portion. The Modeler, Bridge Modeler is where we actually set up our element templates and stuff like that. Prostructures is also linked to this. That's more for rebar detailing, steel detailing. Luminar T is the visual aid that comes along with Open Bridge Designer. It's more for visual aids. iTwin Synchronizer is more towards the end of the project. Once you have your model set up, you're going to want to create an iModel for a deliverable. I'll get into that later. And sync rows control field are more for construction management. So today, the full process is what I want to go through is start out with just scoping your project. You want to consider what you want to be delivering. You want to make sure you have a setup for your workspace before you start building out your models. This is pretty important. You can edit and tweak these as you go, but you want to make sure that you understand what you need before you start creating models. I'll touch on survey, terrain models, and geometry files from ORD. Those are two key elements you need before you start building out your bridge model. Bridge modeling itself, I'll go into a little more detail on that. There's a lot of steps that go in there. I'll have some demos. I'll have some of the processes that you use specifically for OBM, and then transferring to analysis, and eventually to rebar detailing, drawing production, all within OBM linked together, creating reports from that. Once you have all that set up, signed off, creating a digital twin, like I said, incorporating both your ORD and OBM, any other programs you have for deliverable. Sending that iTwin or iModel to construction management and letting them run with it for cutting up their quantities, sending it to fabrication, and eventually combining everything together for an asset management for the client. So let's start with scope. Just touch on this briefly. You want to make sure you set this up at the beginning of your project, setting up your LODs, level of developments. You can get pretty detailed with this, and you should. It's going to dictate how much detail you need to put into each element. You can set up an execution plan and a matrix for this, where at each phase of your deliverable, you want to make sure you establish what type of development you have for each model. I'll show examples of this in the next slide, but you want to set up the definitions of your level of development first. So some of the standard ones, taking a beam for an example here. A 100 level is really just a concept. There's no input there on in the model. 200 is an approximation. Say an example of that would be you've got an approximate size of beam that you think, we got to keep it under 63 inches, and that ends there. So you can represent that in your model for 200, say in a conceptual phase. Moving up to 300 is really where you get a lot more detail. You start to build out some sizes. You can actually rely on some of the information if you've identified it as a level 300. When you're cutting sheets for TS&Ls, this is kind of the level you want to get to. Again, this is specific to beams. You're going to want to make sure that you establish LODs for each element. They're going to be a little bit different, as you'll see actually going forward. Getting more detailed as you get to 350, you're adding rebar. This isn't applicable to things like bearings. You can get to a level 200 bearing that actually represents something that's pretty close. Or you can jump right up to a level 400 bearing where you've started to apply a lot more material properties, maybe some forces and seeing. This is all connected in the element. So you have to make sure that the properties are actually attached to the element in the model. You can't just say, all right, we're going to cut our section and label the properties on a sheet. That doesn't get you that level of development of detail within the actual model. 400 is where you really want to go if you're starting to build out something for construction management or an asset management. This is talking about things like adding an item type to the model itself, to the element. So you've identified what the pay item is within the model. You could add scheduling information, any custom properties you can create. That's something you're getting towards PS&E. Again, if this is the route you want to take with the client to produce a high-level model. Sometimes, I'll move forward. You don't necessarily have to go to a full, it's in this model here, 7D leveled of deliverable. The step for BIM, the first step here is really going 2D to 3D. We're creating a model. We're using that to go through our analysis, make sure that we're not clashing with any utilities. We can use it for quantities, but that's just the first step. You can really add a lot of metadata to these models as you start to add in time elements, construction scheduling, phasing. And this doesn't necessarily have to be added from the design side. You can send an iModel to the construction management as it gets to construction, and they can start to add more of this data along as the model progresses. So workspace setup. before we can start building everything up, we have to figure out what standards we're using. What does what BRIM standards are the client? Do they have any? Have they developed some? Do you need to develop them? These type of standards are display settings, even display styles, line styles, all that stuff you want to do for drawing production, even within the model. What levels do you want to have elements show up on? You've got to set that up in an environment you can work in first. You also want to establish where you're going to be working on a shared network locally. I'd highly recommend using a shared network. That way, multiple users are drawing from the same workspace. You want to consider how it's going to be updated. There are going to be constant new versions of softwares, excuse me, that are released. So as those updates come in throughout your project, how are you going to approach those? So things to consider. The big setup that you want to consider, especially on the OBM side, is your feature definitions. These are things like piers, abutments, your terrain, your support lines. You want to make sure that the feature definition within your workspace is set up correctly. And that starts with setting up your levels, going to an element definition based on your levels, getting feature symbology applied to those, and then eventually putting those into a feature definition that you can then start attaching metadata to, such as any other custom properties you want to identify, pay items, things like that. Moving down your template libraries, and I'll be demonstrating this later as we get into the program a little bit. But you want to set up the location for your material libraries, your templates such as your decks, your beams, your any sort of cell you have for a fence or a bearing. You don't necessarily have to fill out all the templates and libraries right away, but you want to make sure that that file structure is in place before you start moving forward with your project. Seed files. If you plan to cut drawings from your model, you want to make sure that those general seed files are set up ahead of time. Those would include display settings, certain levels you want displayed when you cut a section specifically for an elevation or for a just a cut section or footing. Those could have different display settings. Generally, you want to have an organization level that has your typical standards that you can use on all your projects. That's going to pull in for every single project you open when you open up a new ORD or OBM. From there, you want to make sure you set up your workspace that pulls from the standards that you're using. I know PennDOT right now is working on their standards. They've progressed pretty significantly with ORD. Their next step is to create some OBM standards themselves. You're going to want to pull those into your workspace. And the workset level is your project-specific stuff. If you have a specific template that you want to show for your deck, in this case, you would want to put that in your workset level, so it only comes through for this project. Survey terrain, you want to start with that. You need a couple of these before you get ready to start your model. This is pulled from ORD. The level of detail depends on your survey data, but what you're going to want to do is you're going to want to reference this into your model and use that. You can have multiple terrain models. You can turn them off, make them active within OBM. I'll show this in the next slide as we get to OBM. But you do want to have at least one terrain moving forward before you start to build out your project. This is just a basic surface. The terrain itself can be edited, manipulated in ORD, and then you just attach it simply as a reference, a typical MicroStation reference, into your OpenBridge model. The last thing you need before you start building out your bridge is geometry stuff. You can't start building on a bridge until you have a profile and alignment. They have to be within the same file. Again, you're attaching these based on simple MicroStation references. The key here is you want to make sure that your profile is associated with your alignment. As we get to a few images from the model, you'll see that there's a base detail on a 2D level that's projected down from all 3D elements. And that's key to making sure that your profile and alignment are in the same geometry file as you reference that in. Now, you can reference a single profile alignment in, but that can also be updated later. Specifically for our project, what happened was we ended up running into a case where the vertical clearance was inadequate. We needed to raise our profile. Now, we had already built out several features of our bridge, all the way down to substructures, beams. So when they come back and they want to raise the profile, usually that causes a lot of problems. But in this case, we're able to simply update our reference in our OBM model, and everything slides with it. As long as everything's associated to that profile, it all updates based on the variable constraints you've applied to each element. If you wanted to, you could remove that attached alignment altogether and attach a new profile. Everything works pretty seamlessly to update with that. So let's get into the OpenBridge model itself. I'll go through a few steps of this, going over what libraries there are to pull from elements from, again, from the workspace you've set up. Setting up a bridge, you can have multiple bridges and multiple files. Templates are pulled from the libraries. These are specific to the elements that you can actually apply. The interoperability between your analysis, going to Prostructures to create your rebar detailing or steel detailing. Pulling reports, obviously you want to be able to check this stuff. Excuse me. So you can pull input reports, you can pull summary reports, you can pull quantity reports. I'll go over that as well. And finally, if you don't have your model as a legal document, you want to pull drawings that you're going to want to stamp and check and send as part of your deliverable. So I'll show a few examples of what you want to do to cut sections. So first, libraries. Libraries are pulled from the workspace that you've set up previously for this project. Now there are standard ones that are that come custom with the release of the program, but you also want to build out some that either didn't come from a client's standards or that you built specifically for other projects that you want to pull from. And this can all be done as you're moving through your project. So these libraries hold all the templates that you can possibly use to create your bridge. And I'll show some demos of that in a little bit. Again, you can see the list here from decks, barriers, beams, piers. This is being built out. Shear studs were recently added, splices. An example here I'm showing is the pier templates. There's a list of all the ones that are pulled from the workspace. You can edit these, manipulate these, edit new ones, copy an old one over and change it and create a new one at any time. And that's convenient because then you can export that to your library and it's saved on that workspace for anyone else to use. So the templates are all are made up of the libraries are all made up of templates. Again, what I just touched on was editing, creating custom templates that way. Say you don't have a new PennDOT barrier in your library, you can pull that out, create it, save it as a template, and export that as an XML file and place it in your workspace. And then it's there for all users to then apply to whatever bridge they want to, or to open it up as they check your model. Here's just a quick example of one of the templates that you'd see in OBM. You can create a simple deck with different constraints. These can be manipulated at any time. They would update with the model. And again, these can be exported and sent to other users or placed on the workspace so that other users also see the same edits that you have. And before I get into my demo, just a quick summary of the bridge setup. You will have to identify the alignment and the bridge type before you start building out a bridge. You can have reinforced concrete girder, you can have pre-stressed girders, you can have a steel girder, a slab bridge, but you do have to identify what the bridge type is. And that is the one piece that you wouldn't be able to go back and change. You could create multiple bridges that are different bridge types and associate them together. But unlike all the other stuff where you could manipulate a pier or change a pier template, change a barrier size, location, and everything updates automatically, you do have to identify the bridge type in the beginning and stick with that one. So I've got a few demos here that I'll show. This is right from OBM. So I recorded this earlier. We have an associated alignment and profile already referenced into this, and we've simply gone and clicked Add a Bridge. Select our bridge type. You have to make sure that you identify the correct alignment and profile. Like I said, you can change this at a later date if you have a new profile, but you can't change the bridge type later. Once you've identified a bridge, you can start adding elements to it. Mostly you'd go support lines first. These can be manipulated and changed later at any time, and things will update. You'll notice at the bottom of the screen here, you'll see feature definitions. These have been set up again previously in the workspace so that the display settings and the features of this element are already set up. You want to make sure you identify those. Otherwise, some of the metadata you get later will be coming through. As you can see, it's simple enough to use the interface, type, edit, manipulate, add. This is pulls up a verification box here that you can change later. Just a little bit. So once you've set up your support lines, SKUs, station start and end, will display in the model. Again, a simple right click on here to change the properties, lets you relocate these at any time. I'll show another example here is the next step would probably placing a deck. This is where I'm talking about with the templates. You can select the templates you want from the libraries you've built out from your workspace. Again, a lot of these come already preloaded with the software, but as you build out your workspace over multiple projects, you can add to your libraries of what you've used in the past. And again, these can be edited at any time. So once you've selected your template, there's some constraints you can turn on. You can set decks as analytical or non-analytical. That will help you determine what you want to be sending to analysis. Associating materials for a material library that you've already set up. And again, these can be changed later. At that point, it's a simple point and click. You can locate these offset from alignment. You can locate these in relation to other elements, and again, change it at any point. And you can see as you associate these with the profile, I'll spin around here for a second. You can see that visually it's very accurate. One more video to build out a few more elements from the bridge. So from here, you can really go in any direction. You can add, play this. You can add beams, barriers, build out your substructure, place your pedestals, and you can do a lot of those in just about any order. You probably want to place your beams first, but everything will adapt and update to the other elements as you place them. So here's just an example of going through the beam layout size. You can place where you want to place your beams. You can add SKUs, displays. So you can see the layout was applied to the 2D level there. Once you've selected that, you can add beams to it. Now, remember, we've identified this as a steel bridge, so the steel templates will come up for you here. If you identify this as a concrete bridge, then you'd have access to the concrete library. I will say the PennDOT bulb tees are within the delivered libraries. Those were added, I believe, a couple years ago by Bentley. So here you're just building out your beam sizes. You could drop down from a rolled shape, or you could build out approximately what your sizes want to be and come down and edit those later after you've sent to analysis. You're just applying web thicknesses, applying them to all the beams. And there you go. In a similar manner, you can edit these, right click, change your beams at any time. You can add barriers at any point along the deck. You can locate those offset from each other. Build out your substructure. Again, templates in a similar way. You're pulling the template name from your previously created libraries. And you can see that there's a pretty significant amount of options that come already with the program. These are all editable, so you can take one of these to start to tweak one to your standards. Associate materials with those, it's very important before you send to analysis. Again, these materials are already set up. You can edit those right from within the program here. Send that material library back out to your workspace so every other user has them. So note the feature definition as well is already applied to this specific template. So from here, we're just selecting our supports, placing our beams, placing our piers. And there you have it. If there was a terrain model associated with this one, you could add some variable constraints where it wouldn't simply put in the pier size based on what you inputted in the template itself. You could actually set it so that it would be a certain distance below the active terrain line, and it would automatically update to that. And you could see within your pier report what those distances are and manipulate those as needed. So additional functions I didn't show there, placing abutments, placing barriers in a similar manner. Bearings, you can add beam seats, steps, slopes. As you go further into design, you get into your field splices, your shear studs. All these can be sent over to analysis. Wing walls, approach slabs. Just a side note, approach slabs, there's a function specifically for them coming in the next release. Right now, you could add a second support line and place a non-analytical deck that would act as an approach slab. You could tweak that deck template to mimic what an approach slab looks like. So the interoperability with analysis, that's kind of another big key step in using this. You're not just going to create a model for quantities and for display purposes. You want to actually take those elements and analyze them. There's a couple different options here. There's something what they call BIM workflow, where the parent file is the OpenBridge model itself. It takes all the elements you've created in the model and sends them to the analysis program where you cannot change them at that point. If you wanted to change the size of something, you'd go back to your model and change it there and send it back to analysis. Standalone gives you a little more customization once you get to analysis, but you kind of lose that synchronicity between the two programs. If you use the standalone, then it'll send everything over, but as you change it in your analysis, you can change it in your analysis as you change footing sizes or beam sizes, but it's not going to update in your model if you use it that way. Like I said, leap bridge steel, leap bridge concrete, iron bridge are the three that are associated. For our project, we had a steel bridge, so we used leap bridge steel. I'll be demonstrating that just a minute. It does give you a transfer report as you go from OpenBridge model to the analysis programs. This has gotten a lot more robust over the last few years, where they really show you what the limitations are between the two programs. It's important to follow these. I won't read through all these. I'll just note a couple. Something like bearings, they can right now only handle rectangular bearings, so an associated equivalent rectangular size of a bearing would come in if you would place something other than that. Another one would be barriers transfer over as loads, but not as shapes. Sometimes that can be a little bit confusing when you've placed a specific shape in your model and then you see it in your analysis program and it's just a rectangle. So make sure that you do read through your transfer report and understand what is being transferred over and what isn't, which might account for any sort of unintended or confusion between the two programs. So once you've built out your model, I'll display this here, a quick video. You have sent this over by simple, I'll pause this for a second. This is the Leap Bridge steel interface. To send the model over, it's a simple click from a drop-down ribbon and click Send to Analysis. That report pops up and your model pops up here in the analysis program. This is again using the BIM workflow. So you'll notice on the left, there's not many options to edit features. A couple of them are adding deck rebar. You can manipulate your splices if you need to within this program. But with the standalone, you'd have the option to change sizes of members, whereas using this flow, like I said, you want to change those in the model itself so that there's no disconnect. If you would apply shear studs within the model, then they'd show up here, or you can apply a simple generic composite structure. Adding loads, there's a separate wearing surface option for where you've placed your barriers. Again, the barriers come in as rectangles, but the bottom face comes in at the right size. Support conditions, simple pin roller, but you also have the option for directional stiffness, along with floating ones so that you can apply certain K factors if you have sliding surfaces and you want to account for friction movement. And the big one here is just applying your loads. There's a material library that is associated with this one from the materials you had in your model. There's also a vehicle library that you can edit. Note that this it does have the PennDOT vehicles. I believe you do have to add the P2016, which is a simple clicking on the vehicle library and adding a new load. Here, showing the dead load manipulation. It does come in automatically as composite and distributes the barrier apparatus loads evenly. That's changed simply by going to your SDL distribution and applying the correct percentage to what beams you want to. Or if you wanted to, you could go in and type in your load specifically. One thing to note here is that if you do change loads here in your analysis and then go back and send your model again to analysis for a second time, some of those edits will be lost, specifically the distribution. So you'd have to update those once more. Similarly, the live loads, you can edit your truck loads before you run your analysis. Apply any other loads you want to, such as stay in place forms that weren't modeled, wind loads, etc. 3 types of analysis: line girder, finite element model, grillage. I think I just ran one member here for speed. I'll forward through this for sake of time. There we go. So analysis set. I'll give you a quick visual aid just to check to make sure that things are coming in as you anticipated them. A couple different things. You check your moment diagram, your shear diaphragms. Make sure that you select the right stage that you're applying, the load case you're applying. You can look at specifically the loads from just dead load or from your trucks. Reports are generated from these. This is again just a visual aid to make sure that things are acting the way you want or anticipated. Or if they're not, you can go back and see what's going on at those specific points. Quick design check. You can set limits to what you want to see for under-designed and over-designed. Those reports will come out, anything that's under or over those limits. So a quick example of a report here would be pulling your certain combinations, certain reports, certain section properties or loadings that you want to display. So the question that probably I've asked or people would have is, how does this associate with other programs that we're using? Mainly the PennDOT programs. Is there an interoperability here? As far as I know, PennDOT is not planned to have the PennDOT programs associated with the model. Now, the LEAP programs are right from Bentley, and those do work. We verified those with other programs. The first step moving forward, especially as PennDOT moves towards its plan list 2025, would be to create a model, but not necessarily send that model to a PennDOT analysis. You could do an analysis outside of the model and apply what you find from those analysis to your model. And I'll get into why that's still valuable as we move forward, as we build out our model here. Just a quick touch on the Leaf Bridge Concrete does the same type of analysis. I focused a lot more on the steel there, but if you want to do the same thing with the concrete bridge, you can. The interface is a little bit different than the Leaf Bridge steel. Prostructures, again, operability is the same function where you send it to Prostructures, a different program from OBM, to build out your rebar detailing. Seed file creation here is important again. The generic seed files work pretty well, but you'd want to set up your display settings more for generating your rebar schedules and generating your call outs specific to whatever client that you're working with. So Prostructure is pretty robust. You can reference in specific elements from your model. You can reference in the full model, or you can just reference in certain parts of it so that multiple people can work on multiple places at once. I think that is the recommended workflow, where you turn off all levels except the level you're working on, the feature that you're working on, applying rebar to it, and then reassociating or referencing everything together in at the end. So drawing production, similarly, you're going to be cutting sections from either Prostructures if you've done rebar dealing at that point, or you'd be cutting from the model specifically itself. If you don't have rebar in there, level display settings are key here. You take a cut from a section, wherever you've displayed at that time is going to come through. So make sure that you're setting up your levels specifically in Prostructures to turn off rebar levels that aren't that you wouldn't want to display in a certain cut. 3 different models that they've set up this workspace for. This is a drawing model, and that's basically your OBM model that we just saw earlier. Your 3D elements that you've built out from bridge, deck, substructure, so on. Your drawing model is the first model that you would cut from the model. So on the left here, you see the example of the drawing model. In the middle, the design model. In the middle, you see that drawing model that was created from that cut. Now in here, you can start to associate or automatically associate annotations, callouts of rebar, callouts from dimensions, concrete lines, and anything else you want to play within here. So by doing this, you can manipulate scale, and this comes in as a reference. From there, you would have on the right here your sheet model. You could go right to a sheet model from the design model, but the idea here is that you've got separate associated design models for every single cut you have. And then on your sheet, you can just simply place as a reference onto your sheet, size them as you want, multiple drawing models. Once you get to your sheet model, you can then start to apply associated notes, any sort of tables you want to place on here, a rebar table. And this can be your final product for plant production. Reports. These are some sample reports from OBM. One of the main ones is the input report. Really helps with back checking QA QC. It really lets you see, because it's tough to go into a model and see what was input, what is coming from a already previously designed template. So if you create a input report, you can start to check what a user actually input into the program. Same thing with materials, quantities. Excuse me. Deck elevations. I believe I showed that next slide. Custom elevation reports. You can find your beam seat elevations from these reports as well, and all these would update again based on your associated profile. This was again convenient with our project as we changed our profile partway through to accommodate a further vertical clearance. So you've got your model built out. One of the options you have here is to send for a visualization in reality modeling. We have not done this. I just wanted to point out that this would be a step you could do at this point to really have a visual aid to display to whoever you need to show what you're working on. So this is a big step in finalizing your deliverable, digital twins. So what Bentley uses is an iTwin synchronizer to create an iModel. The idea here is that rather than going in and QCing an OBM or an ORD model and potentially manipulating some of that data, you'd send this all to iTwin, which creates an iModel. And within that, you're not you're linked to your design model, but you're not changing it. So in the iTwin, you can go in for your QA/QC purposes and add notes, add comments, track changes to that model. People can respond to comments about why does this this looks like this is conflicted. Can you check this in the model? And then they can reassociate the updated design model to their iTwin, and that history is checked, and there's a tracking a trail of comments and responses and revisions. At this point, too, you can also attach things like a PDF or an attached hand calc that maybe you had done on the side that doesn't really reflect in the model. You can attach this to a specific element within the iModel. Another key point here is that this associates all of the Bentley programs here, and we focused on Bentley today because that's the program we're using to create our model. But if you've created a model using other software, say Autodesk 360 or maybe Revit or something like that, iTwin allows you to associate those other programs into the iModel and create an IFC open file format so that you're not limited to a specific program when you go into this. It allows you to bring everything together all in one spot. And that's important too as you go through towards construction management. So this way, when you're delivering an iModel to a client or to a contractor, they don't have to have the specific software that you use to design them. Now, Bentley for construction management offers a couple programs that I've seen. The main ones are Synchro Field and Synchro Control. But again, these are just pulling the images here you see from an iModel based in their iTwin system. Just briefly, Synchro Field would be the application that you use in the field to, you've got a geolocated project and you can keep track of tasks, RFIs, certain images, conditions you can attach to a picture to a certain element that you saw, and you can track scheduling that way. Synchro Control lets you previously set up a schedule before you actually start construction. And again, you can associate that with the model and all the metadata that you've already built out from design. Finally, asset management. The idea of building out all these models is to not lose any of the data that you've done through design, through construction, through as built images. You don't want to just drop your model and have it lost as you move on through the life cycle of the project. So for asset management, if you're associating something like sensors on your project, inspections can all be linked to that model, that iModel. Documents can be attached, and it gives a more robust categorization of the assets that are in the field. So with that, that's the end of my presentation. If there's any questions I haven't seen in the chat yet, but again, thank you for attending today. If you have any questions, please feel free to reach out to me. I know this was a quicker, high-level overview of the process. So if you want to get a little more detailed about some of these processes here, please let me know.
Thanks, Zach. We'll give it a few minutes here, a couple minutes, in case anybody is thinking of a question or hasn't typed it in yet. I had a couple that I wanted to run by you.
Sure.
So looking at the level of development, LOD, is there a standard, or is it client specific on how far they expect you to take it at different deliverables in your final submission, or are you only taking it to a low level and then transitioning to more standard, or are you taking it all the way to LOD 400 and giving that to the contractor?
No, so it's client specific. Again, you want to identify it in the scope early. So if a client wants to be using this as a legal document for construction, and the construction wants to use the model specifically as the most trustworthy thing versus the plans, then you're going to identify that level development be the full 400. But that has to be established early on in the project. What we did is, because this is newer, we established our own type of almost LOD, anticipated LOD per phase. And as we move forward with the project, try and make sure that this is the client expectation. Look, this is what we think that we're going to be getting to for an LOD at this phase. Would you like to see us progress that further? Do you think that's too much detail? That's the way we've approached it early on.
Okay, and then for your deliverables at the different stages, are you submitting drawing packages based on the LOD to date, or is anybody actually receiving those IFC or the actual models and doing a electronic review, or is it still kind of a standard?
It's both. Right now, we're delivering a drawing package cut from a model that is built to a certain level of development at that phase. Now we've kind of backed into those LODs to get to the right level of drawing production that they anticipate for certain phases. For a semifinal phase, your drawing production is at a certain level of detail on the drawings. Let's make sure that when we're cutting those from our model, the detail in the model matches what we need to there. But we've been delivering the model along with the drawings, and the model will actually match that LOD anticipated.
Okay, and one more question from me. Then we got one that came in on the chat. I might have missed it. What's the cloud or the central file systems that multiple people can be working in a model and checking it out or syncing their updates into a live central model? Is that how are things typically stored?
So we're using ProjectWise. Bentley's associated with that since that's a Bentley product as well. So our workspace has been saved on ProjectWise and mapped that way, configured so that when you open up a specific OBM version or in ORD version, it loads that specific workspace from ProjectWise. The model itself is really a DGN, and those are saved on ProjectWise as well. So anyone can go in and open that file format. The one thing I didn't point out is, from a bridge side, OpenBridge Designer creates something called an OBDX file, and that kind of houses everything together. From that file, you can open up your analysis right away. You can open up your DGN model right away. You can open up Prostructures on its own, all housed within that one. And again, those files we've saved on ProjectWise as a shared server.
Okay. All right, question in the chat is, can OBM do excavation and backfill quantities?
Yes, it can. I don't know if I have one open now to show that, but that goes in. You have to make sure you have your surface and terrain model active. Based on where you've placed your footings, you can set limits for excavation on slope, on offset. You can account for sheeting by the way you cut through the excavation. And that report is that's a report option as well.
Okay. All right. Well, I think we've had enough time here for people to have a chance for questions. So I think we can move on to wrap up today. I'm going to pull up the closeout slides here. So thank you, Zach. Appreciate your time today. And again, if anybody needs to contact Zach or has any questions, his email address is out there, or you can ask me and I'll get it over to you if you want any further follow-up. So just a couple closeout announcements. Our upcoming meetings for this year. We have December 9th, rehabilitation of a removable bridge. January 20th, emergency repairs of Hernando de Soto Bridge by our own SEI board member, Greg Dunn. And then February 15th is the I-95 Express toll lanes landside stabilization. So watch your emails. We'll send out invitations and reminders for those. Also updated on our website regularly. We'll be filling out the rest of the year as we get that all finally nailed down. And then looking for anyone that can help advertise. We have a yearly scholarship that SEI Philly hosts we're going to be sending out advertisements to the local. It's open to engineering schools in the Philadelphia area. We send it out to the engineering departments of those schools. But if you know a student or somebody else who may be able to qualify, please let us know. We can get them an application and make them aware of it. We'll be looking to advertise in December, and then they've got about 2 months to prepare their application and submit it, and then we award in February and hand it over in April. So just let us know if you have any good students. Please advertise that to help advance those stars in our area. And with that, that is everything for today. Thank you everybody for your time, and thank you again, Zach, for walking us through this.
Great, thank you.
All right, have a good day, everybody.